Now let us solve another problem in flanged beams. So the question here is, determine the moment of resistance of the section shown in the figure. So here he has given us a figure and is asking to calculate the moment of resistance for this particular T section. The materials are M20 grade concrete and HYST reinforcement of grade Fe 4 and 5. So what is the grade of concrete? It is M20 and the grade of steel is Fe 4 and 5. And the remaining data is given in the figure here. And what is asking to calculate? Is asking to calculate the moment of resistance. So if you see this particular T section, what you can observe here? This T section is an doubly reinforced section. As you can see, reinforcement present in the tension zone as well as the reinforcement is present in the compression zone. So it is a doubly reinforced T section. Now what we have to do? We have to calculate the moment of resistance for this doubly reinforced T section. So first let us write down the given data from the figure. So what is the given data from the figure? He has given us the effective width of the flange. What is the effective width of the flange? It is 1000 mm. And the depth of the flange is given. What is the depth of the flange? It is 100 mm. And what more is given? The overall depth of the beam is given, which is 400 mm. And the effective depth is given. What is the effective depth here? It is 360 mm. And D dash is given. How much is the value of D dash? It is 40 mm. You can see here. And what more is given? In the compression zone, as a compression steel, how many bars are provided? 2 bars are provided of dia 20 mm each. So from this what you can calculate? You can calculate the value of area of steel in compression or the area of compression steel. So how can you calculate? 2 into pi d square by 4, which will give you a value of 628 mm square. And how many bars are provided in the tension side? You can see 6 bars are provided, the dia of each bar being 25 mm. So from this what you can calculate? You can calculate the area of the tensile steel. So how will you calculate? 6 into pi d. So the area of tensile steel will be AST is equal to how many number of bars? 6 into pi into d, 25 whole square divided by 4. So if we calculate this, we will get a value of 2946 mm square. So now we have calculated the area of the compression steel and we have calculated the area of the tensile steel. Now what is asking to find out the moment of resistance. So before finding out the moment of resistance, what we have to know? We have to know where the neutral axis is lying. Whether the neutral axis is lying in the flange portion or the neutral axis is lying in the web portion. So first what we have to do? We have to find out the value of XU. So to find out the value of the XU, what I am doing is, I am assuming that neutral axis lies in the flange portion. So assuming the neutral axis lying in the flange portion, now I am going to calculate the neutral axis depth XU. So how will calculate? By equating the forces of compression to the forces of tension. But what we have to consider here? We have to consider the doubly reinforced section. So what will be the forces For doubly reinforced section, 0.36 FCK BF into XU plus ASC into FSC minus FCC. This will be the forces in compression for a doubly reinforced section. Will be equal to 0.87 Fy into AST. That is the area of steel. So these are the forces in the tension. Now substitute all the values here. You know the value of FCK, BF is known, XU is what we have to find out, ASC is already calculated, FSC is what you have to calculate now, and FCC also, the formula for FCC is 0.45 into FCK, which we have already learned in doubly reinforced beam. You know the value of Fy and AST is also calculated. So the two unknowns here are, one is XU and the other one is FSC. So first let us find out the FSC value. So we have already discussed in doubly reinforced beams. How we will calculate the FSC? Here is one way. From D dash by D value, you can calculate the FSC. So what is the D dash given here in this particular question? It is 40. What is the D here? D here is 360. If you calculate this, you will get a value of 0.11. So from the D dash by D value, in the code book SP16, if you consider the table, you will have a FSC value. So the FSC value here is FSC is equal to 353 Newton per mm square. So how to calculate the FSC values and all we have already discussed previously in doubly reinforced beam. So based on that you have to calculate the FSC value. So if you calculate, you will get a FSC value of 353 Newton per mm square. Now substitute all the values in this particular equation. So what it will be? 0.36 FCK. What is the grade of concrete here? It is 20 into BF. BF is nothing but the effective width of the flange. What is the effective width of the flange given here? It is 1000 mm into XU is what you have to calculate plus ASC. What is ASC we have calculated here? It is 260. So what is the ASC we have calculated here? So what is the ASC we have calculated here? ASC is 628 into FSC. FSC is 353 minus FCC. How will you calculate FCC? 0.45 into FCK. FCK here is 20. Will be equal to 0.87 into Fy. What is Fy here? In the question it is given, it is 415 into AST. AST is what we have calculated here, which is 2946 mm square. So if you will calculate this, you will get a value of XU is equal to 117.72 mm. So this is the value. XU is equal to 117.72 mm is what we are going to get if you solve this particular equation. So now from this XU value of 117.72 mm, what can you observe? XU is greater than DF. Either or not. What is the value of DF? It is 100 mm. And what is the value of XU? It is 117.72. Which one is greater? XU is greater. So if XU is greater than DF, then what it means? It means that the neutral axis is lying in the web. So what we have assumed here? First we have assumed that the neutral axis is lying in the flange. But here the neutral axis is lying in the web. As the neutral axis is lying in the web, what we have to do? We have to calculate the new neutral axis depth, equating the total forces of compression to the total forces of the tension. Now we have got the value of XU is equal to 117.72 mm. So now from this what you can observe? You can observe that XU is greater than df. So if xu is greater than df, what? The neutral axis lies in the web portion. So if the neutral axis is lying in the web portion, what this particular xu value is when the neutral axis, assuming that the neutral axis is lying in the flange portion. As the neutral axis is lying in the web portion, we have to calculate the new neutral axis depth by equating the forces of compression to the forces of tension. So now what will be the forces of compression? It is 0.36 FCK BW into XU plus ASC into FSC minus FCC plus 0.45 FCK into BF minus BW will be equal to 0.87 Fy into this is the equation. These are the forces of the compression. So what? 0.36 FCK BW into XU plus ASC into FSC minus FCC, because we are considering here it is a doubly reinforced section, plus 0.45 FCK into BF minus BW into YF. These are all the compressive forces will be equal to the tensile forces 0.87 Fy into AST. Now we have known all the values. Substitute all the values in this particular equation so that we will get the value of XU, that is the new neutral axis depth, considering that the neutral axis is lying in the web. So let us substitute. It is 0.36 into FCK. What is FCK here? It is 20 into BW. BW is nothing but the breadth of the web. So what is the breadth of the web given here? The breadth of the web. So what is the breadth of the web? It is 250 mm into 250 into XU is what you have to calculate, plus ASC, we have already calculated ASC, which is 628 into FSC. What is the value of FSC? We have calculated previously, it is 353 minus FCC is 0.45 into FCK, which is 20 plus 0.45 into FCK is how much? 20 into BF. It is nothing but the breadth of the flange, which is given as 1000 minus BW, it is given as 250 into YF. So what is the formula of YF? YF will be 0.15 XU plus 0.65 into DF. So what is the DF here? DF is 100 into 100 will be equal to 0.87 into Fy. What is Fy? It is 415 into AST. AST here is how much? It is 2946 mm square. Now if you will solve this, you will get a value of XU, which will be equal to 145.37 mm. So this is the value of XU is what we are going to get if you solve this particular equation. So XU is how much here? XU is 145.37 mm. So now what is the next step? What we have to do? We have to calculate the YF value. That is, we have to check whether the YF is less than the depth of the flange or not. So let us check for it now. So what is the value of XU? What we have got here? It is 145.37 mm. So now let us calculate the YF. So YF is 0.15 XU plus 0.65 into DF. So it is 0.15 into XU. What is the value value of XU? It is 145.37 plus 0.65 into DF. What is DF? It is 100. So if you solve this, you will get a value of YF as 86.80 mm. So YF is how much it is? 86.80 mm. Is it less than DF or not? Yes. So YF is less than DF. Hence the value of XU, which is 145.37 mm, is acceptable here. So now after calculating this, what is the next step? What we have to do? We have to calculate the XU limit. So for Fe 415 grade, what will be the XU limit? It is 0.48 into D. It is 0.48 into D. What is the value of D here? It is 360 mm, which will give you, so will be equal to 172.8 mm. So the XU limit value what we have got here, we have got a value of 172.8 mm. Now what? We have to check for XU limit greater than XU greater than DF. So what is the value of XU limit? It is 172.8 mm. That is 172.8. It is greater than XU. What is the value of XU? It is 145.37. It is greater than DF. So hence it is okay. Now what type of section it is? It is an under reinforced section. So why it is an under reinforced section? Because XU is less than XU limit. So what is the value of XU? It is 145.37 mm and XU limit is 172.8 mm. That is XU is less than XU limit. So what type of section is this? It is an under reinforced section. So in an under reinforced section we have two more cases. So what are the two cases? That is DF by XU less than or equal to 3/7 and DF by XU greater than 3/7. Now next what we have to do is we have to calculate the DF by XU. Now we will calculate the DF by XU value. So DF by XU is equal to, what is DF? It is how much it is? It is 100. What is the XU? It is 145.37. So this will be equal to 0.68. So this will be your DF by XU value. So what is the value of 3/7? It is 0.43. So the DF by XU value is greater than 3/7. So what we have got here, that is DF by XU is greater than 3/7. So if this condition is there, so what we have to do, we have to replace YF in place of DF. Okay, so DF will be equal to YF. So wherever you find DF, there you have to substitute YF. Now what we have to do, we have to find out the moment of resistance for this particular doubly reinforced T section based on this particular condition. So based on this particular condition. So now we'll write down the moment of resistance equation and substitute all the values in that particular equation and find out the moment of resistance for this particular doubly reinforced T section. So what is the equation? It is mu is equal to 0.36 FCK BW into XU into D minus 0.42 XU plus ASC into FSC minus FCC into D minus D dash plus 0.45 FCK BF minus BW into YF into D minus YF by 2. Now you have to substitute all the values in this particular equation. That is mu is equal to 0.36. What is the value of FCK? It is 20. Into BW is how much? 250. Into XU, what is the value of XU? It is 145.37. Into D, what is the value of D here? It is 360. Minus 0.42 into XU. What is XU here? 145.37. Plus ASU. How much is the ASU you have calculated here? 628. Into FSC. How much is FSC? It is 353. Minus FCC. What is the formula for FCC? It is 0.45 into FCK. That is 0.45 into 20. Into D. How much is D here? It is 360. Minus D dash. What is the value of D dash? It is 40. Plus 0.45 into FCK. How much is FCK? It is 20. Into BF. How much is BF here? 1000. Minus BW. How much is BW here? It is 250. Into YF. How much is YF? It is 86.80. Into D. What is D here? It is 360. Minus YF. That is 86.80 divided by 2. So if you solve this, you will get a value of mu equal to 332.9 kilonewton meter. And the moment of resistance for this particular doubly reinforced T section is 332.9 kilonewton meter. Now let us solve another problem on flange beams. So the question is, a T-beam as shown in figure is subjected to a factored moment of 400 kilonewton meter. So what he has given here, he has given the mu value, that is the factored moment, which is 400 kilonewton meter. Design the steel reinforcement for flexure. So what is asking to design here is asking to design the steel reinforcement. That is, the reinforcement is to be founded at here. And the materials are M20 grade concrete and H1 is the reinforcement of grade Fe415. And the effective depth is given as 500 mm. If you can see here in the figure, the effective width of the flange is given as 1650 mm and the depth of the flange, it is given as 100 mm and the width of the web, it is given as 250 mm. So what we have to calculate here? Here we have to find out the steel reinforcement, or the area of the steel reinforcement is to be found out here. So first let us write down the given data. So what is the given data? Mu is given here, which is 400 kilonewton meter. The grade of concrete is given, which is 20 Newton per mm square. The grade of the steel is given here, which is 415 Newton per mm square. And the breadth, that is the effective width of the flange, is given here, which is 1650 mm. The depth of the flange is given here, which is 100 mm. And the breadth of the web or the rib is given, which is 250 mm. And the effective depth is given, which is 500 mm. It is asking to calculate the area of the steel reinforcement which has to be provided. So before calculating the area of the steel reinforcement which has to be provided, we have to find out whether the particular T section is a singly reinforced section or a doubly reinforced section. So to know whether if it is a singly reinforced section or a doubly reinforced section, what is the first step what we have to do, which we have already learned in the previous sessions? We have to calculate the limiting moment of resistance. If mu is greater than mu limit, then you have to design for a doubly reinforced beam. So first let us calculate the limiting moment of resistance. So mu limit will be equal to 0.36 FCK BW into XU limit into D minus 0.42 XU limit plus 0.45 FCK BF minus BW into DF into D minus DF by 2. Why? Because here we are considering it as a balanced section and we are going to calculate the limiting moment of resistance. So all the values are known here except the XU limit. So what will be the XU limit? XU limit will be depending upon the grade of the steel. So what is the grade of the steel here? The grade of the steel here is Fe 415. So XU limit will be equal to 0.48 into D. So what is the D here? The effective depth here is 500 mm. So then you will get a value of is equal to, you will get a value of 240 mm. So XU limit how much you will get? You will get a value of 240 mm. Now substitute this XU limit here and calculate the mu limit. So the limiting moment of resistance mu limit will be equal to 0.36 into FCK. What is the grade of concrete here? FCK is 20 into BW is breadth of the web, which is 250 into XU limit. What is the value of XU limit? It is 240 into D. What is the value of D? It is 500 minus 0.42 into XU limit is 240 plus 0.45 into FCK is 20 into effective width of the flange. How much is the effective width of the flange? It is 1650 minus width of the web. It is 250 into DF. What is the depth of the flange given here? It is 100 into 100 into D is how much? 500 minus how much is DF? It is 100 divided by 2. So if you solve this, you get a value of mu limit is equal to 739.45 kilonewton meter. So what will be the mu limit value? It is 739.45 kilonewton meter. So what is the value of mu? Mu is 400 kilonewton meter and mu limit is 739.45 kilonewton meter. So here what? Mu is less than mu limit. So if mu is less than mu limit, you have to design for a singly reinforced section. So what here? Mu is less than mu limit. So what you have to design for? You have to design a singly reinforced section. A singly reinforced section has to be designed. Now what is the next step? What you have to do? For this particular moment, for carrying this particular moment, we have to calculate the area of the steel, which is AST. So what is the equation for calculating it? Mu limit is equal to 0.87 Fy into AST into D minus dF by 2. So what will be the AST? AST is equal to MU. Here you have to write down MU, not the MU limit. Why you have to take MU here? Because MU is less than the MU limit. So for that reason you have to take this particular value MU here. So MU divided by 0.87 Fy into D minus dF by 2. So substitute all the values here. So you know the value of MU. MU is how much? 400 kilonewton meter. Fy is 415. D is 500 and dF is 100 divided by 2. So from this you can get the value of AST. So what is MU? MU is 400 into 10 to the power of 6 divided by 0.87 into Fy is 415 into D. D is how much it is? 500 minus dF. How much is dF here? dF is 100 divided by 2. So if you solve this, you will get a value of AST as 2462 mm square. So this is the area of steel what you have to provide for carrying this particular moment of 400 kilonewton meter. So now what we have to do? We have to calculate the number of bars and the dia of bars required for this particular area of steel. So now let us calculate the number of bars and the dia of the bar. Now what is the AST what we have got here? AST is 2462 mm square. So I am assuming the diameter of bar as 25 mm. So assuming the diameter of the bar as 25 mm, I am going to calculate the number of bars to be provided. So I will calculate n into pi d square by 4. D here is 25. Therefore will be equal to the area of steel which is 2462. So from this you can calculate the number of bars as 2462 into 4 divided by pi into 25 whole square. So from this you will get approximately the number of bars as 5. So how many bars you have to provide here? We have to provide 5 number of bars and the dia of each bar is being 25 mm. So now let us calculate the AST which is provided. So what is the AST which is provided here? 5 into pi d square divided by 4. From this which you are going to get a value of 2455 mm square. So nearly same. 7 mm is only the difference. It is fine. It is okay. So the AST provided here is 2455 mm square. So there is the area of steel which is required for carrying this particular moment MU which is 400 kilonewton meter. Now what we have to do? We have to go for the check whether the AST what we have provided is correct or not. So now let us check for it. Now let us check for the design. The check for design. So for checking for the design, first what I am going to do is I am going to calculate the neutral axis depth. So how will calculate the neutral axis depth? The neutral axis depth can be calculated by equating the forces of compression to the forces of the tension, assuming that the neutral axis is lying in the flange portion. So 0.36 FCK BF into XU will be equal to 0.87 Fy into AST. So 0.36 into FCK. What is FCK here? It is 20. What is the effective width of the flange? It is 1650 into XU is what we have to calculate here, is equal to 0.87 into Fy. What is Fy here? It is 4 and 5 into the AST. What is the AST? What we have provided? It is 2455 mm square. So from this part we'll get the value of XU, which will be 74.61 mm. So if you solve this, you're going to get a value of XU which is 74.61 mm. Now from this what you can say? That XU is less than DF. Is it or not? So what is the value of XU? XU is 74.61 mm and the value of DF is 100 mm. That is XU is less than DF. So if XU is less than DF, then what? The neutral axis lies in flange. That is what we have assumed is correct here, and the neutral axis is lying in the flange. Now, as the neutral axis is lying in the flange, let us calculate the moment of resistance. Before calculating the moment of resistance, let us calculate the type of the section. So, how will you know the type of the section? By comparing the XU and XU limit. So, we already know the value of XU. What is the value of XU here? It is 74.61 mm. So, let us calculate the XU limit. So, how will calculate XU limit? The grade of the steel is Fe4 and 5. So, 0.48 into 415, which will give you 240 mm. So, from this what you can observe that XU is less than XU limit. If XU is less than XU limit, then it is an under reinforced section. So, for this under reinforced section, let us calculate the moment of resistance. So, now we will calculate the moment of resistance. So, Mu will be equal to 0.36 FCK into BF into XU into D minus 0.42 XU, because what? The neutral axis is lying in the flange portion. If the neutral axis is lying in the flange portion, what we have to consider? We have to calculate it based on the rectangular section. That is, considering it as a rectangular section, we have to calculate the moment of the resistance that we have learned in the previous session already. So, as it is an under reinforced section, the value of XU has to be considered here. So, substitute all the values here, then the value of Mu is equal to 0.36 into FCK. How much is FCK here? It is 20. And BF, what is BF here? It is 1650. And XU, what is the value of XU? It is 74.61 mm. And D, how much is the value of D here? It is 500 minus 0.42 into XU. XU is 74.61 mm. So if you solve this, you will get a value of Mu is equal to 415.41 kilonewton meter, which is greater than the moment which has to be carried, which is 400 kilonewton meter. So the design is okay. So what we have designed, the area of steel is correct here. So the design is what? Here it is. The design is okay. So alternatively, you can also calculate the moment of resistance with respect to steel also by using the equation 0.87 Fy into AST into D minus 0.42 XU. So what you will get? You will get the same value. So now let us calculate the moment of resistance with respect to steel. So how will calculate the moment of resistance? Mu is equal to 0.87 Fy into AST into D minus 0.42 XU. So why we are taking this particular equation? Here what we are doing, we are considering as the neutral axis is lying in the flanged portion, we are considering it as a rectangular beam, and the equation for the rectangular beam is used for calculating the moment of resistance. So substitute all the values here. 0.87 into Fy. What is Fy here? It is 415 into the AST. How much is the AST? The AST is 2455 into D. How much is D here? It is 500 minus 0.42 into XU. Why the XU here? Because it is an under reinforced section. That is 74.61. So if you calculate this, you will get a value of 415 kilo Newton meter. Get 415 kilonewton meter. So which is greater than 400 kilonewton meter. So what? The designed one, okay, is greater than the actual moment which has to be carried. So the design is okay. So what is the area of steel what we have provided here? We have provided 5 number of bars, and the dia of each bar is 25 mm. So 5 number of bars, that is 5 bars of 25 mm dia is what we have provided. And what will be the effective depth? The effective depth here is 500 mm. Hence, the check for the design is